Greetings to you. Welcome to Physics with Ben. I am very sorry. I'm deeply sorry for keeping you guys waiting this long. I'm very sorry for not uploading content on NECO practicals for you guys to watch this year. I'm very sorry. I was busy with other activities. However, I am back today for you again. If you are a returning subscriber, I beg you to stay and continue to share my content. If you are just coming in, I just ask you to subscribe and click the notification bell to get notification on every content I upload so that you can enjoy this channel. Before I continue, I want to use this medium to advertise a book written by one of my very good friends, Mr. ASHOGBON.A.O. This guy is a scholar, trust me. He's a seasonal teacher and he has written this book, and I want you guys to patronize him. The book title is Complete Workbook in Physics. This is book 1. This is book 2. And this is book 3. What will this book offer you? As far as evaluation is concerned in education, this book is very important to track your progress in your performance in physics. This book is a book to evaluate your performance in physics throughout the term and throughout your stay in the secondary school. Kindly get a copy of this book. Click in the description box below and you will get the contacts of the author of this book so they can place your order. Without wasting much time, let us go straight to the business of the day. We want to look at a brand new topic: waves, and precisely optics. When we are talking about optics, we simply mean light. Waves is a very broad topic in physics. The topic is very broad. I have produced a video on sound waves. If you have not watched that video, kindly click in the description box below to get the link to everything on sound waves. However, in today's video, I want us to concentrate on just light waves. What is a wave? A wave is simply a disturbance that travels through a medium from one point to another, transferring energy and without a permanent displacement of the medium itself. There are types of waves, or let's say classification of waves. Waves are classified based on material medium, based on direction of travel of the wave, based on motion based on motion or state of the wave. Classification of waves based on material medium, we have electromagnetic waves, we have mechanical waves. Electromagnetic waves are those waves that do not require a material medium for their propagation. Example of such waves is what I write in an acronym called RAMI-VUSGA. RAMI-VUSGA. By RAMI-VUSGA, I mean radio waves, I mean microwaves, I mean infrared rays, I mean visible light, I mean ultraviolet rays, I mean X-ray and gamma rays. What we are treating, light waves, falls under visible light. Under visible light, you have what I call ROIG. ROIG. By ROIG, we mean red, we mean orange, yellow, green, blue, indigo, and violet. These are the colors of light you have under visible light. However, we are treating just light waves, visible light in today's lesson. The other classes of waves, we have to call them mechanical waves. These are waves that do not require a material medium for their propagation. Before I continue, believe that light wave can travel through material medium and what without a material medium. It can travel through vacuum and also what through what material medium. So the other classes of waves are called mechanical waves. These ones, they don't need a material medium. I mean, they need a material medium for their propagation. Examples of such waves include water waves, sound waves, etc. I have produced a video on sound waves. Kindly click in the description box below to watch this video. We want to look at the last classification of waves, which is based on direction of travel of the wave. Here we talk about longitudinal waves and transverse waves. Longitudinal waves are those waves that travel in the direction that is parallel to the direction of their propagation. Examples of such waves are waves on the spring. However, light waves, which we call transverse waves, these waves travel in the direction perpendicular to the direction of what? To the direction of their propagation. We call them transverse waves. So that is where light waves belong to. And then the other classification is based on motion or based on what state. They're talking about progressive or traveling waves, and they're talking about standing or stationary waves. Standing and stationary waves was treated in sound waves comprehensively. So let's go straight to the point. We want to look at the general properties of waves right now. The general properties of waves. There are 5 general properties of waves, which light waves has all of them. Sound waves has just 4 of them. Watch that video and you'll understand what I'm talking about. Number 1, properties. By properties we mean the behavior of light waves as they are propagated, as they travel through space and out of space. Number 1, we have reflection. We have the reflection of light waves. Number 2, we have refraction of light waves. Number 3, we have diffraction of light waves. Number 4, we have interference of light waves. And then number 5, we have polarization of light waves. However, in this video, we will not treat all this. We want to concentrate just on reflection of light waves. Reflection of light waves is what we want to concentrate on. In another video which I am going to produce, we'll still look at reflection. It's a very broad topic. And then also refraction. In this series, I want to concentrate on just reflection and refraction. So please be following me up so you can watch all the videos. So let's go straight to the point. What do you mean by reflection of light waves? Reflection of light waves simply means the bouncing back of a ray of light as it hits or encounter a reflecting surface. To this, we want to look at types of reflection. We have 2 main types of reflection. We have the regular reflection and the irregular reflection. We have types of reflection. Under types of reflection, we have the regular reflection, and what we have the irregular or scattered We have the regular reflection or uniform reflection. We have the irregular or scattered reflection. Please, I want you to know that every item you see on the table here, on the board here, are simply areas where if examiners want to ask you questions, they must touch. So please pay maximum attention. So we have the regular reflection or uniform reflection. We have the irregular reflection or scattered reflection. What do we mean by regular reflection? Regular reflection is simply the reflection that occurs at smooth surfaces. Under regular reflection, you have a diagram like this. You may have a plane mirror like this. And then the rays will hit this way, the incident rays. And then they will reflect uniformly in one particular direction. We call this type of reflection uniform reflection. So this is the plane mirror, and this is the incident ray, and this is what the reflected ray. For the other one, the irregular reflection, this is regular reflection. For the irregular reflection, what do you have? You have something like this. It is a reflection that occurs on rough surfaces. A reflection of light waves that occur on rough surfaces. Here, the incident ray, the incident at different angle, and they are reflected at different direction. A ray may incidence this way and reflect this way, and reflect this way. So you see that this is more organized and this is more disorganized. So we call this irregular or scattered reflection. Reflection that occurs at rough surfaces. We call this uniform or regular reflection. Reflection that occurs at plane or smooth surfaces. The next thing we want to look at is the reflection at plane mirror. Reflection of light at plane mirror. This is what we call in physics plane mirror. If you look at this, you will see your face in it. This is what we call in physics the plane mirror. Coated one side with silver and this side as the what? The reflecting side. So we want to look at reflection at plane mirror. The reflection of light at plane mirror, here we talk about the laws of reflection and also the principle of reversibility. The laws of reflection are simply just two of them. We have just two laws of reflection. So let's look at them very, very quickly. I'm going to use this diagram to explain what I mean by the laws of reflection. Draw a plane mirror. If you pick up your plane mirror, this side is this side, and the up is the reflecting side. That is what you see representing the diagram like this. So if we draw a normal perpendicular, let's call it NO. If we draw a normal perpendicular to the surface of this mirror, and then we try to incidence a ray of light at this angle, this is our incident ray. So the first law of reflection states as follows. the incident ray, the reflected ray, and the normal, they all lay in the same plane on the plane mirror. The incident ray, the reflected ray, this is the incident ray I, and the reflected ray R. And the normal NO, they all lay in the same plane on the plane mirror. Law number 2, the angle of incidence I is equal to the angle of what? Refraction. I is called the angle of incidence, while R is called the angle of refraction. The angle of reflection, sorry. So, what we are trying to say here is that the I is equal to what? R. And if I is equal to R, it implies that I is equal to what? 2R. Or R equals to what? 2I. This is the law of, the laws of what? Reflection. We want to quickly look at something under this law called the angle of deviation. Supposedly, if there is no plane mirror here, as the ray of light is traveling down here, the ray is supposed to travel down, straight down this way. However, there is a surface here saying this ray will not pass down. And so the ray has to reflect up this way. And so we say that this angle from the normal to this place is called the angle of what? Deviation. The angle of deviation, take notes, we have gotten one equation here. We say that our I is equal to what? 2R. Or our R is equal to what? 2I. From the second law of reflection. So mathematically, the angle of deviation D is giving us 180 degrees minus 2I, or D is equal to 180 degrees minus what? 2R. This is the equation for the angle of what? Deviation. Please take note, we're going to be using this equation shortly to do some little calculations. The next thing on our list, we want to look at, we have touched this, and I said we concentrate on reflection. We have touched this, we have also touched this. We want to look at the principle of reversibility. The principle of reversibility is simply a principle that says that the path with which the light ray travels upon can be reversed. What is that? What's the meaning of that? It means that if we choose here to be our incident ray, maybe here to be the point where we point our laser, lasers are polarized light. If we point our laser here, the light will reflect this way. And so here, if we try to bring our laser this side, this place becomes our incident ray, and this place becomes our reflected ray, and this angle becomes our incident angle, and this becomes what? Our angle of what? Reflection. This is simply what we mean by the principle of reversibility. As simple as that. We want to look at the characteristics of the images formed by a plane mirror. When you stand before a plane mirror, what do you see? The characteristics of the images formed by a plane mirror. 1, we have what is called lateral inversion. The image is laterally inverted. The image is laterally inverted. What do we mean by that? We mean that letter P will appear as what? Letter Q. As letter Q, when you present it when you place it in front of, P, we appear like 9 when you put it before the plane mirror. And your F will appear this way when you put it before the plane mirror. We call this lateral inversion. Number 2, the image is virtual. What do you mean by that? The image is virtual. What do we mean by that? By virtual image, we mean that the image cannot be cut on the screen. That is the meaning. The image cannot be cut on the screen. The image is not real. The image is unreal. That is the meaning of that. Number 3, we say the image is same size as the object. The image is what? Same size as the object. The image is not diminished. The image is not enlarged, but same size as the object. Number 4, the image is behind the mirror as the object is in front of the mirror. The image is behind the mirror as the object is in front of the mirror. Number 5, the image is upright. When we say the image is upright, we mean if you stand before the plane mirror, you will not see your legs up and your head down. That is what we mean by the image is upright. What if we look at the image is formed by an inclined plane. We are almost done with this lesson, and what you do the calculations. When you incline 2 plane mirror the way I am holding them in my hand here, what do you see? Something like this. And you put an object in between them. You observe that the object, you will see multiple images formed in between. If you try to close in the mirrors, the 2 mirrors together, you see that the number of images will be increased. We have an equation that explains what is happening here right now. This equation is simply giving us number of n. N is equal to what? 360 divided by theta minus 1. Don't forget, we are looking at images formed by a plane, by inclined mirrors. What's the meaning of this one? This one is simply the object that was placed in between the 2 mirrors. One simply means minus what you are seeing here physically. That is the meaning of the minus 1. The minus 1 stands for what? The object placed in between the 2 plane mirrors. And so to this, we want to look at some simple calculations before we call this a day. I'd like to pick one calculation here in one of the book of my friend here, and then we do justice to it. If you pick up this book, this is page 80, complete workbook in physics, book 2, page 80, question number 21. I read. An object is placed between 2 plane mirrors which are inclined at an angle of 120 degrees and facing each other. Determine the number of images observed in the 2 mirrors. Very simple. From this equation, we have our data collection as well. Our theta is given as 120 degrees. And so we are supposed to find n. N is not given. So by plugging this into this equation, we have this implies that our n, number of images formed when those mirrors were inclined with each other, is given as 360 divided by 120 minus 1. This will go, you have 36 divided by 12 minus 1. Do that correctly, what do you have? uh, we have 3 minus 1, and your n is equal to what? 2. So therefore your n is equal to 2. So the number of images formed when the angle of inclination is what? Is 120 degrees, is just 2. Meaning, I want to throw light to this equation before we move on. What's the meaning of this equation? The equation simply means this: when the angle of incidence, when the angle of inclination between the two plane mirror increases, the number of image will decrease. Meaning, there is an inverse relationship between n and theta. So decrease in the number of images will cause the number of images to increase. Let me just practice that here so that you see it quickly. This is first inclination. What do you see? If I decrease the angle, what do you see? Please drop your comments in the comment box. Thank you. So we will look at second. So for you to get more of this, kindly pick a copy of this book and help evaluate yourself. We still want to look at more examples. Right now we are looking at examples on what I just stated. Let me say what example. Sorry. We don't have time. What examples? Let us look at another question here quickly. This one is very, very simple. The diagram below shows, this is page 80, book 2, page 80, book 2, question number 23. The diagram below shows a ray of light IK. This is the diagram below. This is the ray of light. The ray of light IK. The ray of light IK incident on the plane mirror K. This is the plane mirror. Incidence on the plane mirror K. Calculate the angle of deviation of the ray after reflection. Take note, this diagram is not complete. The angle of incidence, because the angle of glance is 35 degrees. The angle of glance, the glancing angle is 35 degrees. This diagram is not complete. What is missing? Let's drop the number to the plane mirror. So this number will be drawn perpendicular to the plane mirror. Let's call this NK. NK is our number. So here is the incident angle. The guy is asking us to calculate the angle of reflection. The angle of deviation after reflection. So remember, I told you that if there's no plane mirror here, this incident ray is supposed to move down straight. Right? And then from the second law of reflection, the angle of incidence is equal to what? The angle of what? Reflection. And your R is equal to what? Your 2I or your I equals to what? Your 2R. Please take notes. So here is our incident reflected ray. And so we say that the angle of reflection will be equal to what? The angle of what? Incident. So from the normal to this point, we call it the angle of deviation. This is what this guy is asking us to calculate. So your glancing angle is given as what? Your glancing angle G is given as what? 90 minus what? I. 90 minus I. So what do we say? We say that our I is equal to what? 90 minus what? 35. Do that question, what do you have? You have 55. So I is what? 50 what? 5. I is what? 55. Glancing angle is what? 90 degrees minus incident angle. So your incident angle is what? 55. So if I is 55, it means that our R is also what? 55. So write 55 here. So what do we write now? Our D is equal to what? 180 degrees minus what? 2I. 55 times 2, you have 110. So your D is 180 minus what? 100 and what? Minus what? 2 times 55. You do that correctly, what you have? You have 180 minus what? 110. So, our angle of deviation, I suppose, is what? 70. Yes, 70 degrees. 180 minus 110. Yes, our angle of deviation is simply what? 70 degrees. This angle is what? 70 degrees. I hope that was very, very impressive. So please get a copy of this book and do more of these calculations. When next we meet, I will produce a video purely on just calculations in waves. It was nice having you. Don't forget to subscribe and share this content. Bye bye. God bless you.